Okay, well, at this stage you will have made it through the weekend. I'm obviously not recording this on Monday. It's still Friday in my land. But I hope you all had a lovely weekend and managed to get out and get a bit of fresh air, and hopefully you saw some folding somewhere happening. Right, again, another kind of short, snappy class today, you'll be glad to know. And all I want to look at are the types of folds. So there are 5 types of folds, and these are in your booklets and pages 5 to 6, but you'll notice that I haven't actually included the diagrams. So I want you to know the fold types, and I want you to get the diagrams into your booklets. And then I'm going to refer you to a task on OneNote or Class Notebook. Okay, it's really, really important that if you're not accessing these or you don't know what this is about, that you let me know, because I want everybody doing them. I suppose it's that simple. Right, I feel, look, I didn't realise that was there. So many computers. Right, let's get going. Okay, so 5 types of folds. The first one is a symmetrical fold, and it is so called because it is symmetrical. So basically that means if you were to draw a line down the centre of the fold and fold it over, nice little pun there, that each sides are equal and it would match. Does that make sense? So a simple fold or a symmetrical fold is one where both limbs, okay, are equal. So they have the same kind of angle or degree, and you can see a symmetrical fold here, and the centre of that fold would be around about there-ish. And that's not a great centre, but you look. So in this case here, pressure has been applied equally from both sides. So the same amount of pressure coming from the left and right side, which means that it gets folded equally. Let me do a little demonstration of that. So, behold symmetrical folding. Equal amount of pressure, symmetrical fold. Next one is asymmetrical folding, okay? And in this case here, the slope of one limb is steeper than the other. So this limb here is steeper. Does that make sense? And here we have the steep limb here. So you can see, here's the symmetrical fold. This limb here is much steeper than this limb here. And this is because more pressure has been applied from one side. So there's been greater pressure here than there has been here. Okay, so you get an asymmetrical fold. I know you're dying for a demonstration of this. So asymmetrical fold, I'm going to apply more pressure from this side here. Okay, so you can see that this limb here is steeper than this limb here. That's asymmetrical fold. I'll just show myself down here because it's easier. Right, now I will put up the diagrams of these separately, so don't worry about that. Go away you. Next one there is an overfold. So basically an overfold is just a continuation of the asymmetrical fold. So again, you've got the steeper limb, but in this case here, this limb is being pushed over that limb. Okay, so this limb is now, look, it's on top of that limb there. Okay, that's why it's called an overfold. Way more pressure coming from this side, hence the big pressure arrow. Okay, and the fold axis, so the axis is here, is almost horizontal, and a really good example of it here. So here's one limb, the other limb, and you can see very almost horizontal fold axis, and this limb is almost on top of that limb there. Okay, now if the fold axis is almost horizontal, it's referred to as recumbent. Barely comes up, but just in case you see it. So here we go, overfold, loads of pressure from this arm here to the point where you see the limb. If I had 4 hands now, this would be grand, where the limb is on top of this limb here, okay? And the axis is almost horizontal, so that's overfolding. And you can still identify the anticline and the syncline in them. This one here is the overthrust fold. So this again is a continuity of being much more pressure applied. So this is where there's huge compression, and folding has been so intense that it actually causes the rocks to fracture along a fault line. So basically, if this continued and continued and continued, there would be a fracture or a fault here in the rocks because they could no longer take it. So in this case here, folding is so intense that the rock ends up breaking. The upper limb is pushed up over the lower limb along a fault line. So this would originally have lined up with this, okay? But because faulting was so intense, it broke, and this whole section here got moved forward. So now this is out of sync there. So you can see it here. Here is the fault line. All right. And if I just change colors, this layer of strata here was originally lined up with this layer of strata here. Okay, so a huge amount of pressure coming from this direction. Why did it delete me line? Okay, so this would have been an overfold. Pressure continued to apply. It snapped this whole bit, jumped forward, so it's out of sync with the bottom limb. Okay, and there's a fault line there. And there will be loads of this in the Himalayas. So this is an overthrust fold. So an overfold, it hasn't broken yet, there's no fault. An overthrust fold is when the fault occurs. And then the last type are the chevron folds. And these are basically folds with straight limbs and very sharp hinges. Now this is the hinge here, okay? So the hinges are very sharp. Here's a sharp hinge. And you can see these in the rock type there, and these are also the folds. We can see examples of chevron folds, overfolds and overthrust folds at Loch Shinny, and hopefully you'll be paying that a visit one day soon. Now a couple of exercises here. Dum da dum da dum. I am going to throw these up on what's called OneNote in your class notebook, and it's going to go into homework and task section, and what I want you to do is answer them. Now what you can do is you can write the answers on a sheet of paper and you can insert the image beneath the task, and that's also fine, or you can type your answers onto the page where the task is, okay? So this one is the previous one is a fill in the gaps one, so that'll be going up. All right, and it won't bounce back and forth like this. This one here, I just want you to label the parts of a fold and the types of fold that we've just done. All right, so A and B equal, go away, get rid of me, I think I'm complicating the issue. So A and B is just the parts. So what part is this? What part is this? These one here, C, D, E and F, are what types of fold, okay? So what you need to do is draw the diagrams in page 5 and 6, then you need to go to OneNote, and then you need to complete those two small tasks. Okie dokie. And apparently tomorrow, yeah, I'm a bit annoyed at this. I know I'm not annoyed at it. We all need a catch up. Tomorrow is a catch up day, so get caught up, or if you're caught up, take a day off and relax. I'll be getting caught up with some corrections, I think. So I hope you all enjoy a nice day chilling out tomorrow, or a nice day catching up. And you know, if you are catching up, you'll feel good after you've done it because you're starting on a clean slate. And again, if people haven't been engaging, I just want you to come on board for this part of the course for deformation. Don't worry if you missed a lot of earthquakes. We'll start from this. Okay, I will check in with you again on Wednesday. So enjoy your Tuesday. And please let me know if you're having issues with OneNote or class notebook, and we'll find ways around that. Adios.